going to help me think about what the heck is this three-dimensional. Well, let me put these numbers down. What was the number here? 2, 1, 0, -1, -2. These are the z values, right? They're k values as level curves, but these are the z values. And at height at 2, you got that. At z equal to 2, that's what it looked like. Little square. Height of 1 is bigger. Height of 0, it's even a bigger square. Height of -1 is even a what? Bigger square. Height of -2, it's even bigger. We know what's going on here? It starts with a P. Pyramid. Now this is just a pyramid. And that's all you got here. It's like, there's that big thing. You don't even have to label z-axis. It's just going to keep getting what? Each one of these will get smaller, 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 and like, this is a pyramid. Pyramid. Just a rough sketch. You go, do I have to sketch the z-axis? Nope. You're just indicating you have an idea what this would look like three-dimensionally just by looking at level curves. And that's good. That's good. You're able to look at this and think about what is that three-dimensionally? It's a pyramid. It's just a pyramid, right? Well, because between 2 and 1, there's an infinite amount of level curves in it. Cool. Hey, flip that over. Draw a contour map. What do they mean by contour map? Same thing. Draw a contour map. You know what they mean? The level curves. The level curves. What if you deal with like temperature, like we did before in depth? It was like temperature, depth, the one on the previous side. Had day of the year and depth. They call those isothermals. Well, contour maps are just sketches of the level curves. You indicate before it's in the xy plane. Here's the function. You're going to draw a contour map of that function of x and y. So the first step, what do you do? What do you let z equal? Let z equal k. That's how you draw a contour map. Okay. That's step 1. Step 2, you get the pick k values. Step 2, you get the pick k values. Alright? I'll get started. No one care if I use k for 1? So I'm just picking k values to make these sketches. Daggone it, that's not a circle. That's not an ellipse. What do you call that, a hyperbola? Hyperbola, Alice? Yeah. It's a hyperbola. That's a hyperbola there. So when I am going to sketch this hyperbola. Hyperbolas go like this. But sometimes they go like this. I got this memorized back from pre-calculus. It's not that bad, everyone. Which way these are hyperbolas? Are they going like this? Down here, or maybe over here? What I do is, I just use an intercept. For instance, can I let x equal to 0? Mm-hmm. So I'm just going to check this out. What would be going on at x equal to 0? See, intercepts get me out of any jam. If x equals 0, right? Then what would y be? I'll put a question mark here.
That becomes a height.
If x equals 0, can I get a point?
Imaginary, yeah.
So nothing's going on at x equals 0. Interesting. Do you all agree? Nothing's going on here. Just put a big what? That can't work, but I do believe we can let y go 0. Let's see about that. What if y goes 0? I bet.
Plus or minus.
Okay, now we got points. So now this helps us understand which way these curves are bending. There's a point right here. There's a point right here, -1 and 1. These curves are just going to come out like this. Just like that. What about here? Nothing's going on in the y-axis. Now before I forget, do you remember I always label this? What was the k value? K equals 1. How about over here? What did k equal?
2.
K equals 1, right? It's the same curve. Okay, hey, let's pick another k value. How about k equal to -1? Now hell do I have there? And I'm going to rearrange that. Can I multiply negative 1 on both sides? By golly, it's another hyperbola, isn't it? It's more hyperbolas, huh? I'm going to let k equal negative 1. It's more hyperbolas. Well, let's try the intercept method. Can I let, I'll try it again. Can I let x equal 0?
Yes.
Ah, works now, works now. What's the y value?
Plus minus 1.
I'm telling you, when it comes to these hyperbolas, ellipses, when you got to make sketches of ellipses and hyperbolas, just use the intercepts. Or that previous problem, the three-dimensional sketch of a plane, use the intercept method. Works every time. I'm going to plot those. Right here, and right there. I'm curious, can y equal 0? No.
No.
So this, like this. There we go. Just hyperbolas like this. Now what's the k value? I gotta label it.
Negative 1.
That's good enough. You got it going there. If you use k equal to 2, you would have got more out here. K equals 3. If you use k equal to negative 2, you would have got another one here, another one here. If you wanted more level curves. But I do want to point out another one. This is cool. What if k equals 0? Sometimes it's fun. You just go, well, what if k was 0? What do you get?
Oh,
Finish
x
this sketch.
squared equals to y squared. X
Now
equals
that's not a hyperbola. Take the square to both sides.
x equals to y.
Yeah, y would equal plus or minus
X.
what is that? Right.
Straight line.
2 lines. You all agree? Y equals plus or minus x. Y equals x is like that. Y equals negative x like that. There'll be lines that go right through this. And I'm going to do it right now. I think I got enough room to squeeze right through those curves. Here. And then what? Here's the level curves of this thing. Now I got to label these. What was k equal to?
0.
K equals 0. Here. K equals 0. You got it. Nice.
This looks like an asymptote.
Yeah.
Right?
It's neat though. That's what I always can do with this stuff. I want to do number 8 together. So what they want us to do, this is like the one we did earlier. Sketch level curves. Remember, I'm going to use that word manipulate. You might want to manipulate it first. And then we'll think about what does it look like three-dimensionally, okay? By the way, great job with this. So a big portion of section 14.1 is level curves. Do you notice that? I just want to point out, it's not the whole section, but a major portion of this is level curves of a function of x and y. See, sometimes you'll notice even on my practice set, I'll just go, I want you to ask me to make a sketch, I'll just go, what are the level curves of this? And I'll put answers. Letter A, are they circles? Are they lines? Are they hyperbolas? Are they ellipses? And you'll think about it, maybe make a sketch just to see what it is. So they want you to draw level curves, a contour map of the function of x and y. What is this thing? This thing looks crazy. 100 over 1 plus x squared plus 2y squared. Okay? And by the way, this is real life application. They're talking about this. What is this representing? This is a temperature. I mean, function f was called big letter T. Capital T stood for temperature of a thin metal plate. A thin metal plate located in the xy plane has temperature T of x and y at point x and y. Draw a contour map. They wrote isothermals because it's dealing with temperature. Draw a contour map, isothermals, of the function showing at least 3 level curves. So we're going to draw 3 level curves of this. When we're done though, I was wondering if, once again, can we use this to make a rough sketch of the function of x and y, which in this case was a big T. And we'll do that again. All right, let's start out. Now, level curves, xy plane. Well, the first thing is, step 1, I like z equal 1. Okay, yeah, there's my z. Let z equal k is my first step. before I get lost with level curves. So let's equal k. I get k equals 100 over 1 plus x squared plus 2y squared. Here's my recommendation though. I didn't write it on the board, but I go step 2. Oh, you just got to pick k values and make the sketches. How about this? Step 2. Take this equation and manipulate it to your liking, and then pick k values. See, if I start picking k values now, I don't know what that really looks like in the XY plane. It looks complicated to me. But can you rearrange this? It's like, can I multiply 1 plus x squared plus 2y squared on both sides? They would look good. So I get 1 plus x squared plus 2y squared multiplied on this side, divide the k, I get 100 over k. That looks a little better. I don't want that 1 over here. I like to have my x squareds and y squareds on one side. So how do I get that 1 over here? Over k minus up 1. Now I like that. I know what these are. I know what these curves are. Think of this. This is just going to be constants. These will be constants on the right side. They're not circles, but they're what? Ellipses. They're ellipses. Very good, Channeling. They're ellipses. If it was x squared plus y squared, same coefficients in front of x squared and y squared, you got a circle. But this makes those ovals, where one's a 1 and one's a 2. So we're going to get a bunch of ellipses. We'll just sketch 3 of them, okay? Ellipses. I need you to help me pick, what's a family of ellipses? Mathematicians use that word family. It's a family of ellipses. Help me pick some k values though. That was a good one. Now let's let k equal 50. Alright, so if you let k equal 50, 1 over 50 is 2, 2 minus 1 is. That was a good one. That was a love it. Now, how do I sketch this? I use intercepts. We're going to sketch that daggone thing, and we'll put a 50 on it. Let's go on at x equals 0. Ugh. Plus or minus 1 over square root of 2? That's okay. And what if y is 0? What do you get? Plus or minus 1. By the way, that number right there, you can hit a calculator. That work? Because y squared would equal 1 over 2. If I let x equal to 0, y squared would equal 1 over 2, but what would y equal? Plus or minus the square root of that, which would be 1 over square root of 2. You know, square root of 2 is like 1.4, so as long as we know this number is 1 divided 1.4, you know, it's going to be less than 1. But this will be at what? 1. So you can see which way is it more stretched. Right there at 1, but if I do a 1 here and a negative 1 here, I mean, does anyone want to hit on a calculator? What's 1 divided by 1.4?
4.
It's point something.
What? 1.4.
1 divided by 1.4. I'm just curious. 0.7? So I can go through these points, but it's like I'm trying to go through about 0.7-ish. Just to get a nice rough sketch. That's right. And I'm going to label it. What's the K value? 50. Isothermals. Oh, the temperature of the thin plate. Right there. Any point along here, the temperature is really hot. It's 50 degrees. Is this Celsius? They didn't say. All right. Hey, we need another K value. 20. I like that too. She goes, let K equal 20. I get x squared plus y, x squared plus 2y squared equals 4. Now let's sketch this. What's going on at x equals 0?
Plus minus root 2.
Okay, plus or minus root 2. What's going on at y equals 0? Plus or minus 2?
2.
2. Got the negative 2. But these, that's about 1.4. So 1.4 would be about right here. Negative 1.4 would be right there. It's not a circle, but it's an ellipse, isn't it? These are ellipses. Not circles, but ellipses. Because this is negative 2. And that's 2, so it went through there. And I'm going to label this with a what? 20. Hey, one more level curve. You all are good. K equals 10. I got enough of them right here. K equals 10. What do you get? X squared plus 2y squared equals
9.
9. So some intercepts. At 0, it's plus or minus, what would be that?
3 over root 2.
3 over root 2. And what if y is 0?
It's plus 1 of 3.
Intercepts get us out of anything. Ellipses, hyperbolas, heck, even when we sketched that plane earlier. Here's my little curve. I just think got out to 3, but then again, 3 divided by 1.4. I mean, that's closer to a 2, isn't it? Right? And I'll label it with a 1. And these are ellipses. So they're not circles, but they are ellipses. So can you make a rough sketch of this? All right, I'll just do here z-axis. I won't even draw the x and y-axis. Can you tell me what's going on? What's going on at a height of 10? There's a height of 10 on the z-axis.
That's the biggest.
Really wide, really wide. All right, so just gonna make a really wide, distorted looking ellipse. What's going on at a height of 20? Did it get bigger or smaller?
Smaller.
Okay, smaller, distorted. And what's going on at a height of 50?
Smaller.
10, 20, 30, 40, 50,
Smaller.
even smaller. There you go, just rough sketch. Think you can go further, you can, you make a point, there you go. Do a good job with that.
Looks like an inverse square. Right.
Yep. And we're almost done with section 14.1, which mostly dealt with what? Level curves, what was the other topic? Domain and range. I mean, sometimes you just, at the end of the course,